not go at the right pace. Am I right?
Not yet.
Because if you don't explain this, then it seems like you're just rushing through it, you know? Anyway,
Okay.
it's fine. Bye. Okay, students, welcome back. I trust you had a good break. I've just been going through all my slides, and I think I need to increase my pace, but I also don't want to lose the essence of the lectures by going too fast. That will be defeating the whole purpose. So I probably won't finish all the slides, but at least it's there for your consumption. But I will try and go through as many as quickly as possible to ensure that you get a good understanding of what's happening with ICT. So the last slide was on slide 9, how information technology impacts the organization. So the next slide, which my technician will change, will be digital basics, slide number 10. Now this is a very interesting slide, okay, just for you to understand how information technology works. And some of you probably want to know how we receive our signals on our cell phone. It's very, very interesting, but that's a whole nother subject on its own. You can just put my little thing at the bottom so I can see that. Yeah. So that's another chapter on its own of how we receive our signals. But I'll go over it very briefly. So basically, we're coming back to digital versus analog. Okay? And this all again showing the importance why the computer uses zeros and ones. So any kind of information can be digitized, okay? Because of the technology that we have today, any form of sound clip, we can create a digital sound of it. So digital is a long string of numbers, right? And believe it or not, it's zeros and ones again. And analog is continuous waves. And analog is what you see on the screen there, the waves that take this form, okay? And then when we receive analog messages on the telephone or via the modem, that modem there then converts the analog to a digital conversion. That word modem is actually an acronym which means modulate and demodulate. So the question I have for you here, okay, as I'm speaking now, what is it, analog or digital? Any student to answer this question? Anybody? As I'm talking to you now, is it analog or digital? Anyone else want to challenge that? Nobody? Okay, you are correct, because the human ear can only interpret analog information, by the way. It's analog, right? So that's what we listen to. The sound waves comes into our eardrum, it goes into the 3 bones, the hammer, anvil and stirrup, and then it converts it into signals into the brain, and that's how the brain interprets it. So the ear is analog. But now that's a problem for the computer. Am I right? Computer doesn't understand the continuous waves. Computer only understands zeros and ones. Correct? And you go to the next slide, it will show an analog signal, and that's what an analog signal looks like. Okay, it's a continuous waveform, and it sounds very sweet and melodious to the ear, because the ear really understands analog sound waves. Now if you take an analog sound wave and you take a digital clip, if you listen very carefully, you will find a difference between the two. Okay, the digital clip is the next. Let me just see if is a slide on this. No, so I have to draw this on the board to show you what a digital clip looks like. Okay, so let's see if this red pen. So digital clip. So digital clip looks something like this. Okay, so zeros, one, zeros, one, zeros, one, zeros, one, zeros, one. Okay, so that's a digital clip. So when you're talking, let's say for example over a modem or a phone, this is analog from your mouth. So analog is this here. These things are all dry.
Yeah.
So analog is coming in like this, also dry. Also dry. Okay, you understand this is analog, which looks like that. Okay, and then goes into digital. There's a modem over here. This is all dry. Shucks.
Yeah, that's like caps.
Okay, these pens are all dry, but you get, but you understand. So you'll have the analog coming here, and then you have a modem sitting over here. Modem's a little box like this, okay? And this modem's got intelligence built into it, converts that analog signal into digital, then goes through the computerized signal, and when it comes to the other end, it's got the modem again into analog. So that's basically how that signal works. Just to give you an idea, it's very technical. You don't need to memorize that. Okay? So at the end is computer, digital, modem, analog. That's how that whole procedure works. So the slide 12 that you see in front of you, you'll see that the digital signal, the next slide, the digital signal is a discrete waveform. Okay, and you can see there's 0 bits and there's a 1 bit on and off. It's always on and off, and that's how it works. But this works at such high speeds, okay, that you cannot see the breaks in between. But if you're a sound engineer, you study sound engineering and audiology, you'll be able to see those little sound clips. That's why sometimes when you are watching satellite TV or TV or whatever, those are all digitally transmitted, and you have the breaks, and you will be able to hear the sound breaks if you listen very carefully. Okay? Was there a question?
Please,
You breaking up?
put up the screen, please. We can't see it.
The screen? The slides?
Yes, the slide.
The slides are on.
We only see NN, Prof.
Yeah, it's minimized.
Okay, you only see NN, they can't see the slides.
Yes.
Okay, let's
It's
see.
minimized.
Let's see if the technician can fix it. Is everybody only seeing NN?
Yes.
Okay, just give it.
Yes.
But can you see Mark? Can you see me in the corner somewhere?
Yes, we can see you.
Okay, I'm not important. The
We don't
slide,
see your face, only your name.
only my name. Oh. Okay, technician is trying to figure out what went wrong. But can you hear me in the meanwhile?
Yes.
Okay, so while he's trying to figure out, just tell me when it comes right, okay? He's busy doing something. Just,
Is it right now?
this is right now. Okay, what happened is something that's
Someone took over.
Oh, because the students, please don't take over the screen, because when you take over the screen, it messes up the stuff on my side over here. That's what's causing it. Okay, so don't take over the screen and share whatever, because that's what's causing the disturbance. Alright? So the digital signal, as I was saying, is a discrete waveform. The analog is the wave, and the digital is in square block and zeros and ones. And then we have that's what we call data communication. That's how we communicate. And then we have this thing called the modem, which is a little box, which actually modulates and demodulates analog to digital. That's very technical, but I just thought I'll let you know what that is all about. Okay, how that works. The next slide, students, you will see is a, let me just change a bit, is a little case study. I take it all of you being the good students that you are, that you have enrolled, that you have read the case study. It's a 1 pager, not 15 pages. And those are the questions that come up on that case study. So let's see who are the diligent students that have managed to answer those questions. Alright, anybody? This was the UPS, United Parcel Services. They went from a paper system to a paperless system. They used technology, and you can see how the technology really pushed them to the next level, how they became very, very competitive, and to ensure that the packages can be delivered accurately and they know exactly where the package is. And this actually happened today with all the various courier companies out there. It's called track and trace, and know exactly where the parcel is. Okay? So anybody, the first question there is, what are the inputs, processing, outputs of UPS package tracking system? Can anybody give me an answer to that? Those of you that have read the case study. Now remember, I'm not going to give you the answers, otherwise I'll be helping you to fail. You're supposed to have read the case study, and I made sure that it's not longer than 2 pages, and the questions are very, very, very simple. And the reason why I do this, so you have a break just from listening to the monotonous voice that you hear all the time, for some of you, and just for you to get some insight as to what I'm trying to say and the message, and how I'm applying the stuff that I'm teaching you into a real life situation. So just to recap, this was a courier service.
Langa has a hand up.
Okay, Langa, is it Langa?
Langa, yeah.
Okay, Langa, please proceed. But unmute yourself, Langa. Langa, we can't hear you.
We have a hand up.
Is that an old hand, a new hand?
Yeah, it much more than progress. Process. They are also able to retain this. It's more like
Okay, the audio quality is very, very bad. I can barely hear what you say. Can you type it in the chat box? Maybe the technician can read it out to me. Your audio is very bad. I can't hear you. Is there anybody else that would like to answer any of those questions there? Let's make it easy. How about the last question there? If you can answer that one, I'll really appreciate it. Anybody, because this affects you as well. Okay, imagine if you didn't have any technology in your company. What would happen if these technologies that you're using are not available? I'm asking these questions. I want to get your understanding to see whether you actually understand the importance of technology after the few slides that I spoke about earlier on. Anybody, the last question, number 4. What would happen if these technologies, whatever technology you're using, are not available? Pamela, go for it.
Okay. Let me attempt. Using these technologies, they were not available. I would think that it would take us back to the paper-based technology that we used to have, where it would take forever for even delivery of parcels, transmission of information. You know, if the technologies are not available, it would make it very difficult to communicate across the globe, as well as providing services to the people, especially in structural development.
Alright, that's correct. Anybody else?
Romy,
how about question number 3, Romy?
okay, she got a hand up. Rakhwale.
Okay, the next one, Rakhwale. Remember, there's no right or wrong answer.
Yeah, but my input was on I was still on form before you said another question to the other link. My input was actually on the flip side of the benefit, but on the non-benefit or the damaging part. We all know that after COVID lockdowns, they they are saying the word greener is over. So maybe the technologies were not there, like the word is are saying on the positive side. So as you saying that India this morning with boost to technology. So it becomes a bit more difficult for Europe to marginalize without complexities of technology.
Okay.
Thank you.
Thank you so much. Thank you for taking the time to read the case study and to attempt these questions. These questions are very important because they're not difficult questions, but it just probes your mind to think beyond what you're doing on a daily basis. So I would want you to go through because there's so many slides and we really don't have a lot of time, and I'm hoping that no load shedding takes place, that we get through most of the slides. But if you need to do another session on the case studies that come along, we will do that again. But these case studies are very important because it's applying what happens in the real business to the IT stuff that I'm teaching you. So these are not difficult questions. The answers are somewhere in the case study and on the previous slides that I've spoken to you about. Okay, so I will, something that there is not many of you have read the case study or you're struggling to come through. I will allow you to answer those questions by email or whatever method you want to speak to me about the case study. But it's important, you will really learn a lot by reading these case studies and putting it into practice and putting the knowledge that you gain into practice. So we're going to go to slide number 14. Now, remember early on my earlier slide, I said to you there's data, there's information, there's knowledge, and how all of these things come together. Now, at the very first screen, you see there the zeros and ones. That is data. Okay? Now, that is data, it's meaningless. You can't do anything with it. It's zeros and ones. You can't interpret it. The computer can do nothing with it. It's the language that it reads it. So that is what data is all about. So people say, you know what, I don't have, okay. So be careful here now, okay. The data that you buy on your cell phone is different to the data that the computer understands. The difference between the two. The one on the cell phone is called a data bundle. And the data that I'm talking about is the information or I can't find another word for data, but the ingredients, if you want to call it, that the computer needs to churn out to convert it into information. Okay, do you understand that? So remember, data as you would normally understand it is not the data that I'm talking about. The data that you understand is a data bundle that you are buying to put into your cell phone so that you can connect it. That is something totally different. The data that I'm referring to here is the ingredients that the computer needs to analyze into bits and bytes and zeros and ones in order to churn that into the next step there, which is called information. Now, information is more meaningful to you because you can make some sense out of it because you can process it. Remember earlier on there was zeros and ones. When you punch into your name, the computer sees it as zeros and ones. In the background there's algorithms that's converting it into your name. Now that is information. It's now readable, you can understand it. Okay, now once you've got information, which is processed data. Okay, so data is unprocessed information and information is processed data.
Okay.
Okay, don't get confused. Okay, data is unprocessed information and information is processed data. A lot of people get this wrong. So information, you can do something with it, you can do some form of interrogation with it, it's got some form of intelligence in it. But then, if you take that information to the next level and you see the light at the end of the tunnel, and now you can see you get something called knowledge. Alright? So, like I say, information is processed and knowledge is you got an understanding and you can apply it to a business problem. Like I said, knowledge comes with experience. Okay? So as you get better and better at the job, you then become more knowledgeable about the job, which you know how to interpret the information more correctly and the data, which is very important. So suddenly now you are knowledgeable. I'm working from the bottom up. You are so knowledgeable now that you know what the information is supposed to be telling you. But if the information is wrong, you would know that the data that was captured was done incorrectly. Remember, garbage in, garbage out? You will only know that in the knowledge part there when you have accumulated the knowledge over many, many years. For example, if you're working on an Excel spreadsheet, alright, and let's say there is 100 students doing a course ICT, and over the past years you know that only 100 students supposed to have been registered for the course, because that is a capping limit. And suddenly you look at the spreadsheet under knowledge, you're looking at knowledge spreadsheet now, and you say, but here's 150 students, how is this possible? Based on your experience, you know that only 100 students supposed to have been on this course. You now know that the information is incorrect because somewhere along the line the data that was captured was done incorrectly. So now you see how important the knowledge is. You're going backwards. Knowledge, information, data. So in order to get information right and the knowledge right, you must go and fix up the data, because someone captured the wrong data. They probably captured a person twice, or they put an incorrect entry in the data. Now, the question is, as a manager, right? You are a manager in your company. What is the most, and I want you people to think about this carefully, and I'm not going to go on until I get an answer. But this is very important. If you don't get this right, then everything else that I'm going to talk about is going to be meaningless. What is the most important step in this triangle? What is the most important construct or variable or item in this three pieces of things that I gave you? Is it the data? Is it the information? Is it the knowledge? Can anyone tell me? You don't have to put your hand up, just shout out the answer. The question is, what is the most important construct in these three items over here? Is it the data? Is it the information? Is it the knowledge?
The knowledge.
Information. Someone said knowledge. Someone said data.
Is the data? Without it, you cannot have information and you cannot
Without the data, it's data process.
Okay, if you're not answering the question, please mute your mics.
Rob?
Yes, I'm listening. I'm waiting for more questions, more answers.
Yes, for me it's data, because without data we cannot have information and we cannot have knowledge. So yeah, for me data is critical.
Very good. Can anyone tell me at the moment, what is the Zondo Commission using at present? You must have watched Zondo Commission. I'm testing your knowledge now, right? What is Raymond Zondo using now in the commission?
Information. Remember, they're busy interrogating, investigating.
Okay.
Information.
Information. What if that information is untrue?
Yes. Come again, bro.
What if that information is untrue? Where does it have to go to? And we all know some of the information that we've seen on the Zondo Commission, some of it is untrue.
Then they will apply the knowledge that they have.
Okay, anyone else? What is Zonda always on about? For those of you that are watching Zonda Commission, what I'm trying to do here is I'm trying to link information technology to real life situations, just to show you and to prove to you how important information, communication and technology is in our everyday lives, and it cuts across all spectrums. And I just right now picked up Zonda Commission just to give you an example, because everyone is listening to Zonda Commission right now, or most people are listening to him. The question is, some of you said data is important, some of you said information is important, and some of you said knowledge is important. So my question to you is, what if the knowledge is untrue? Where do you think Zonda is going to go to, and what is Zonda always asking for?
Prof, we would go back to the elementary description of things and go back to the basics, which
Right.
is the data.
Correct, there we go. So do you understand? That's the point I'm trying to drive home here. Zonda is always looking for evidence. Another word for that evidence is data, the correct data. So if he has the correct data, he can have an informed decision, and from that informed decision, knowledge will be created, and then he can put these buggers behind bars for stealing our money. Okay? Because you all of you supposed to be having a very, very good education, and it's enough money for all of that. So that is how important it is, that that data is so critical. If that is wrong, everything else below that is wrong. Even the knowledge that's coming from information without that evidence will be incorrect. Do you understand the importance of the data? So I want you to think about this very carefully, because along the line I'm come back to this point and prove to you how important your job, everyone that's on this course, why you are the most important entity in your organization. And you can go back to your boss and tell him I told him that, and he must give you an increase. And I will prove, and you can use my analogy to prove to him why you need to be paid well for the job that you are doing. And we're going to use ICT to do that. And it's very simple. And we're going to get you that. Okay? So this is technique and tactic that you need to go to your boss and tell him why you need an increase in your salary. When you come off this course, this is one thing that you've learned, is to go back to get a promotion and you get a better increase. Okay? Let's start guessing. So, very important, that's the important thing on this slide here is that data in, if it's garbage, data out is going to be garbage. Okay? So, rubbish in, rubbish out. So, important, put in proper information. Now, what is computer-based information systems? So, this slide here is, I tried to put the slide so you can get a bit of bits and pieces and put the whole thing together again, so you can see one picture of what computer-based information systems are all about. So on the left hand side there you will see the computer, the hardware. You will see the databases, which I spoke about earlier on. Then you see the network at the bottom there, on the bottom right, and then you'll see the software. And then in the center, okay, you'll see the cockpit. And I'll show you another screen right at the end, how they all fit together. But what is the most important thing out of all of them that's linked? Remember, all of these are linked. The hardware is talking to the database, which is the software, which is talking to the network, which we'll come to later on, and it's talking to the software. And we have all the screens in the center, which is called the cockpit or the dashboard. But my question to you is, what is the main driver of all of these things? Those four things. What is the common denominator, as you would say in mathematics? Anybody? Remember, there's no right or wrong answer, it's how you motivate. So I'm giving you a picture there, and the picture is, what is the most important factor in fact, give me two, make it easy for you. In this particular diagram, in the sketch here. And these are what we call a computer-based information systems. They all work together. That's how all of this stuff that you're seeing, that we're doing right now, is working using that over there. Okay, we've got a network running here. We've got cameras running there. We've got software running there. We've got computers running here. As I'm sitting here, all of that stuff is in that diagram there. But there are two important things here that's more important than all of these things. If you don't have that, nothing will work. Can anyone tell me? Remember, it's not only you listening to me. You have to ask me questions as well. And that's how we learn from each other. As I'm learning from you, you're learning from me. So quickly.
Because I think hardware and software.
Okay, carry on. Anyone else? Anybody else? The question is, what are the two most important aspects in this diagram?
The software and the network.
Okay. Anybody else? Okay, so I see you all thinking very, very hard about this, and you're over-analyzing, and you're going into deep thinking now, what is this guy on about? And the answer's in front of you. If you look at all four arrows there, what do you see? Everything is linked with an arrow, and it's called procedures. Right? So that's the first important aspect. The procedures that links all of these things together. But students, over and above the hardware, the software, the LAN, the network, the procedures, the programming, there is still one very, very important aspect that brings all of these things together. And you must answer this question.
It's called computer-based information system.
Anyone else? Quickly. Over and above all of these things here, there's one important aspect in this whole diagram. Quickly. Okay, let me get you out of your misery. So, you've got all these hardware, software, procedures, and all of these things working together. But if you take out one person, if you take out the human aspect, if you take out the people aspect of this whole equation, nothing works. Do you understand that? And again, I'm coming back. If you don't have the skill to operate the network, if you don't have the skill to operate the database, if you don't have the skill to write the program, if you don't have the skill to set up the hardware, none of this, I promise you, can work. So that is why it's so important, and I'm stressing this point again, that you must skill yourself to work and upskill yourself to know how technology works, right? So you are the most important person in this whole equation. If I take you out of this equation, meaning if I take the human being aspect out of computer-based information systems, nothing will work. Okay? So you might ask this question. It might be one of you that are quite clever here. I know all of you are very clever. So one of you might ask you this question. So NASA sent Perseverance to Mars. Perseverance is, by the way, the robot. You all know Perseverance, the robot that went to Mars. It landed on Mars successfully, and now it's taking pictures of Mars. Right? So how do you think that all happened? We're like a good couple of million miles away from Mars. Can anyone tell me how that Perseverance, when it got close to the orbit of Mars, that it managed to find the crater where it managed to land itself in the exact spot. How did that all happen? By itself? Using robotics, yeah, certain point of it. But what actually happened in that whole procedure is something called artificial intelligence, robotics. Okay, and that's how that managed to land safely in that particular area at the exact location where they wanted. Obviously, using cameras and sensors and GPSs and all of those things that they use. But that is what it was. But if the human being wasn't involved in that whole story, nothing would have happened. So you are important. That's what I wanted to show you. We can send a mission from here to Mars, but if you take the human aspect out of it, it won't happen. It cannot happen. Because the human brain is nothing more powerful than the human brain. No matter what computer you have. And yes, we know computers are becoming intelligent, and some of them are very intelligent, and they're actually overtaking the human being. But the human being is still the most important person in the brain behind it. Okay? So this is the human being that has done that. I just wanted to elaborate the point to show you that the human beings are important. Okay, so people, that's you and me, are the important aspect in the whole computer-based environment and society. We'll move to the next slide. So this particular slide here, a lot of people also talk about this very, very loosely. So I just thought I'll put it here for informational purposes. The different types of operating systems. Remember I said earlier on, you get software applications, you get software systems, you get applications, and we get something called operating systems. Okay, now the operating system tells your smartphone what to do, how to do, tells your laptop what to do, how to do. Okay, now for Windows, you all know for your normal computer, we have Windows 10, and that was developed by Microsoft, and that's called the operating system. As the name says, it operates the computer. Okay, and then with the MacBooks, now MacBook is the competitor for the normal Windows stuff. Okay, so the MacBook, which is the MacBook Air, your the iPhones, the iPads, the iPods, everything with the Apple in it, they got their own software. Okay, the operating system that's developed by Apple. And then Apple also got the iOS software. They got two software, okay, also developed by Apple. And then you got your normal phones, which is your Samsung, your UE, and what other cell phones you have there, the different Sonys and whatever. They use Android. So now sometimes when you go to a cell phone vendor, they ask you what Android you have or what Windows operating software. They're just talking about the operating software that you're using. And then there's another software called open source, which is called Linux, okay, developed by a Finnish person. So that's open source software, and it's free for everyone. And that's also software that's used to use in computers to operate your computer. And there you can see at the bottom it's available on laptops. The first one, the second one is on the Macs, on laptops, desktops, all-in-ones, and iOS on iPhones, iPod, iTouches. And then your Androids on smartphones and on tablets, and then the open source on most desktops and tablets. I just thought I'll put this here to show you what the different software is all about and where it's being used. Okay, so we can turn the page on that one. And we can change the screen. So now, what is a computer network? So the two things that you normally speak about very, very loosely, as I spoke about earlier on, is bandwidth and broadband. I'll explain these two things to you so you don't get confused between the two. So bandwidth is the bits per second, like I told you earlier on, and the maximum data transfer. Okay, I'll explain it. I'm going to make an analogy later on. And then broadband is something else. Is the connection of the bits per second, 100 megabits per second. So how am I going to explain this to you now? So in your mind, think of a normal garden hose pipe. Okay, you picture the hose pipe in your mind. Now think of the hose pipe is about 25 millimeters thick, am I right, in diameter. Right? Now that's what we call the bandwidth. The diameter of that hose pipe is the bandwidth, because when you open the tap, only certain amount of water can go through that that hose pipe, because it's only 25 millimeters in diameter. The more you open the tap, the faster that water is going to go through. That is broadband. That is the speed at which the water is going through that hose pipe. Okay? So the more you open the tap, the faster the water is going to come through. The faster your broadband, the faster information you're going to be coming to your phone. So if you want a bigger bandwidth, what you're going to do, you're going to have a bigger hose pipe, because if you have a bigger hose pipe, more data, voice and video will be coming through the pipe. So that is the difference between bandwidth and broadband. A lot of people don't understand this. They talk about it as if it's the same thing. It's not the same thing. Broadband is speed, bandwidth is the size of the pipe where the speed is traveling through. Always remember that. Okay? Now there's two networks that we have. The local area network and the wide area network. And as the name suggests, the local area network is probably in the company where you are sitting and all the computers are all linked together in your company. It's local, but it's not going beyond the perimeter of your particular company. But let's say you've got a company in Cape Town, Durban, Pietermaritzburg, Grahamstown. So you've got the same company spread in the 9 different provinces, and when you link them up, that then becomes a wide area network. So that's the difference, okay? If it's contained to one place, local area network, different regions, wide area network. And how do you connect them up? Via that thing called a router or router. Router is a little intelligent box that moves information or data to the various places via the network cable, okay, or Wi-Fi. We'll come to that later on. And then we come to the next thing they call enterprise networks. So we have a network in South Africa, and we have one in Canada, and one in Mauritius, and one in India, connected all over the world. That's enterprise networks. And then we talk about the corporate bandwidth networks. We will talk about that on the next slide. And we will talk about software-defined networks. Okay, now software-defined network is got some form of intelligence built in there. It's programmatically efficient network. So basically the program's got intelligence built into it. So it tries to improve network efficiency. It uses software to manage it. There's no hardware involved. So it automatically tries to heal the network by itself, like self-healing computers. So these are all the technical things which when you're sitting in front of your computer, you don't see. This happens in the background, and the IT technicians are busy with all of these things in the background. So I just wanted to give you a glimpse of what happens in the background, because sometimes when you're working in front of the computer and things don't work, you're always complaining why things don't work. So at least now, when the computer's slow, when things go down, you would have a good sense of why that is actually happening, or what's happening in the background. Remember, this is hardware, and this is software, and there's environmental factors that affect the computers. So that's the biggest thing in the living in the digital world. We are all bound by environmental factors, by hardware and software. If we have an earthquake tomorrow, or something happens with the underground cable in the sea that links South Africa to the various parts of the world, then our internet is gone, our Google is gone. We have to wait until it gets repaired. Okay? But there might be a solution for that. I'll see if you will think about that solution. Right? How we can get away from the cables and the Wi-Fi and all of those things. There is a solution. Let's see if we will come up with a solution as we go along. Okay, the next slide. Now, this is a slide which actually is a very good slide, and this slide will tell you where you are sitting and how it's connected to the rest of the world. Okay, so you're probably sitting, let's say some of you are sitting in finance, some of you are sitting in marketing, some of you in HR, manufacturing and accounting. So you're just sitting behind your laptop or your PC from home, and you're working away merrily. But if you look at the picture from a helicopter view, this is what it actually looks like. You have the various functional departments in your company that's connected by either the wide area network or the local area network, depending if your company is a multinational or a local company. And then you have a mainframe computer sitting somewhere that looks after all of those various functional departments. And then you've got your file server there, which is the backbone to your wide area network. So in your case, you just think, hey, this computer is a silly computer, is connected to this cable here, but you don't know what's happening in the background. That is how you are all connected. And this whole thing here, this diagram is called the enterprise network. Enterprise meaning very big, huge. It's not limited to your small little area. So I put this diagram here so you can see exactly, you know, you are only one little minute speck in a wide spectrum of things. But at the end of the day, you are all connected. And that connectivity is called ERP systems, Enterprise Resource Planning. Connects all of them together, and hopefully when we get time, we're going to talk about it later on. Okay? So, can students tell me how our call centers operating? How are they all connected? Or could I ask the question in another way? Do you think call centers operate like this? And by the way, just to give you an eye, that corporate backbone that you see there in the yellow, do they also see the yellow?
Yeah.
That corporate wide area network, that yellow black circle around it, that is fiber optic, by the way, because fiber optic is the fastest medium where you can transfer information and data. We'll talk about that later on, okay? So can I ask the question, true or false? This is how call centers operate using an enterprise network. Anybody? I'm asking a question, true or false? Is this how call centers operate? Come along, students, this is not a difficult question. Either yes or no. Are you guys there?
Please repeat the question, Prof.
Okay, the question is, do you think call centers operate using an enterprise network the way I showed you on the screen? The way it's depicted there, do you think?
Yes, Prof.
Yes, and why do you say so? Come on, tell me, why do you think they operate like this? Is there another way for them to operate? Let's make it easier for you. Anybody? Yeah, okay, so you are correct. It's operating on a LAN and a WAN and an enterprise network. Because you could have a call center in Cape Town, you could have another one, a backup one in Taiwan, okay? And you could have another one in London, and they're all linked on the same network. That is why sometimes when you phone in for help on the internet, you will find that you're speaking to a foreigner in a different country, but you're dialing a local number. And this is how they operate on this diagram that's shown in front of you. Okay, because sometimes, remember, one country, for example, Australia, is 8 hours ahead of South Africa. London is probably on the same time zone, or 2 hours ahead. So in order to get maximized productivity, they want to use 24 hours in the day. So they use the time difference in a different country to ensure that productivity is carrying on all the time. So if you have a question in South Africa and it's 8 o'clock, we'll ask a question that will pick up, hey, South Africa is alive, so let's let them answer the question. But hang on, if they're too busy, it's another time zone in another country that can answer the question, so they can answer the question for you. So they use the various time zones in a different country on a call center to ensure that your question gets answered. But this is how global IT works. So do you see the power of a simple call center using that enterprise network, how it can be of a value to a business. Okay? So that is the importance of IT and how an enterprise, a local area network works, and a wide area network works, and an enterprise network. So let us go to the next slide. Now this seems like a mathematical trigonometry problem, am I right? So have any of you ever wondered how the message, how the email leaves your computer and how it gets to the other side of the world? Any one of you ever think about that? And on your cell phone, the voice, okay, that works slightly different. Anyone think about it? How your email?
Yes.
Okay, so let me explain this to you. It's actually quite simple, by the way. But think about the creativity and the knowledge that went behind this, making this so simple. So you are in New York City over there, and you've got your email message there. Okay? So what the software does, it breaks up your email into packets, into various packets. Okay? So you have, let's say your email is constituted of 6 packets. So packet 1 will be the header, packet 1 and 2 might be the header, packet 3, 4 and 5 might be constituted as the body, and packet 6 will be the tail. Okay, there's more to this explanation. I'm just giving you a very, very basic explanation. Okay, so you got the header, got the body, and you got the tail. That is your main message as you are sitting right now in your company. Now you want to send the email from New York City to Los Angeles, or you want to send it from Cape Town to Durban. So what the computer does, it takes that email and it breaks it up into those various packages, and you can see how it routes it. So it finds the next possible router using your internet service provider, and it breaks it up and it jumbles it up. You can see packet 1 and packet 4 is going to Chicago, packet 3 is going to Atlanta, packet 4, 5 and 2 is gone to Dallas, and packet 6 found a straight way of going to Los Angeles. The tail part of it went to Los Angeles first, and packet 1 had to first go to Chicago and then come to Los Angeles, and the rest of the body went through different routes. So what it did was, it broke the email up and it sent it to the various routers, and then when it reaches Los Angeles, there's a router there. It knows packet 1 is the header, packet 1 and 2 is the header, packet 3 and 4 is the body, and packet 6 is the tail. And when the email comes together, it reassembles it very quickly, and then you get your email. So that's how it works. It finds the fastest route across all those networks and different routers to the endpoint to get that email there. Isn't that amazing? Using zeros and ones. Sometimes when you receive an email, the email is corrupted. Am I right? Or you can't read it. Looking at the diagram there, can any student tell me why do you think your email or your attachment got corrupted? So I hope you understand the power of email and why it gets corrupted after this explanation. Anyone? Tell me, why would your email get corrupted or your attachment get corrupted?
Wouldn't it be that by the time it gets to the end or the destination during assembling, it's not assembled properly, or the piece could not read and reassemble properly? Thereby, by the time you actually open the email, it's unable to read all the different components, whether it's the header or the content or whatever the case may be.
There we go. Perfect answer. So sometimes during the way the packet gets dissected, it goes to the various places in Chicago. Maybe when the packet 1 and 4 reached Chicago, there was a breakdown in communication. Either the cable got disconnected, or the router there or the modem there was malfunctioning. So that part of 1 and 4 got stuck, right? Was waiting for someone to fix it up. But the rest of the emails traveled fast and it got to Los Angeles. But for some reason it didn't reassemble itself correctly like explained. That is why when you open it up, it's completely corrupted. And then what do? You swear at the person that's sending you the poor person that sent you the email in good faith, you curse him to the limits because he sent you a faulty email. But be well, that is how your email gets delivered. Okay, so I hope you understand now. And this happens very quick. Sometimes you send an email now, in 10 seconds the guy's reached it already. That's the power of the network when you're using fiber optics and the router and the modem. So that is how dependable we are on technology. So if the hardware and software goes down, then your emails will be faulty and corrupted. Okay, so I hope you all understand that. Okay, so I thought I'll put that in there just so you understand that the directional arrows are missing there, but they're all going towards Los Angeles, because that's where the final destination is. And that the protocol that controls all of this is now another lecture on its own. It's called TCP/IP, Transmission Control Protocol, Internet Protocol. Because the Internet's got a certain language that it understands. You cannot just put any language on the Internet and expect it to know what you're talking about. So a protocol is a set of rules and regulations which is used on the Internet so the Internet can function correctly. So that diagram there, I want you guys to think about it carefully and to know about it. So when you have slow emails coming through, or when you say no, the email is slow or the Internet is slow, it's not that. It is how the packet is being dissected and where it's going, you don't know, and how long it takes to get to you. Okay? I hope that was a bit of good, useful technical information, because a lot of people don't understand this. Are there any questions before I move?
Yes, but can I ask a question?
Yep.
All along I've been thinking that if the information is corrupted, that's because of my computer is exposed to virus. So how does that play a role in all that?
Yeah, so there's three things by the way. The third way, that the second part where the email could be corrupted is that you have a virus on your computer that messes up the file structure of that email that you're sending. That's the second part, and that is something we'll talk about later on when we come to security. And the third thing is if you are a hacker. You know what's a hacker? Where you hack into people's computers and you want to try and steal their information. That's when you can also steal people's information and distort the way the information has been encrypted. So there are three ways where you can get corrupted information. That is why it's so important to ensure that you have an antivirus program, and there are quite a few of them on the internet that are readily and freely available just to protect your computer against any viruses, because there are people that are quite destructive. They want your information, and as you know, there was a big scam many years ago, not in the recent past, where people's emails and IDs were all stolen and taken. Even this Flickr thing, there was a big story about that, where you're supposed to Flickr and suddenly your Flickr information was sold to marketing companies, and now suddenly once you bought a new cell phone and they ask you for all this information, and they take that information and they sell it off to marketing companies, which they are not supposed to do, by the way. It's unethical. And then suddenly you're finding people phoning you on your phone for this advert, for this product, for that service. You didn't subscribe to that, you didn't ask for that, but this is how unscrupulous some companies are. They take your data, your information, and they sell it to survey companies for money. And that's how you get caught when these people phone you. And just to digress very quickly, on the cell phones, nowadays people are sending these these emojis, and then you get these the sticky stuff, and what's the other thing, Vic? The funny faces and all of those things. The stickers, am I right?
Stickers, yeah.
So sometimes in those
Text.
stickers, yeah, the text, sometimes in those things, you got to be very careful. I'm just telling you about this. They could be, because it's very difficult to get a virus on your phone. Okay, it's very difficult. But what the hackers have done, they've embedded viruses in those emojis and in those sticky things. Okay, like the funny faces and the things that bounce about all over the place. they embed viruses in there so it comes onto your cell phone. That's the way of them getting it onto your phone. So try not to use those things on your phone, because a virus can now corrupt your phone as well. So just be very, very careful on that, alright? So try not to, in fact, tell your family, don't send you those sticky things and that funny faces and the things that bounce about all of that, because it can cause nonsense on your phone. And you know your life is on your phone. All of you have your lives on this phone. So you don't want that to go missing, like I explained earlier. You can lose your husband, your wife, your children, your money, whatever, but you don't want to lose your phone because you are so dependent on that phone. So take care of it, don't open those emojis. Right, so let us go to the next thing, a bit more on hardware. You can just change that slide. So this is the cable that we used in the old days and we're still using now. It's called twisted pair. This is funny enough where your data travels through your 0 and 1s, travel through this. This is called an Ethernet cable. Different color codes mean different things. This is still from the old technology. We are moving away from that now. Just to give you an idea of how these things work, okay? That's what we call Ethernet. The next one is called the coaxial. You can change the slide, Vic. The next slide. This is called coaxial. Most of you are probably familiar with this. The middle line there, you've got the copper cable running through it. Some of your TVs run through this as well. You connect your TV up to it. And you can see all the cladding around it to protect the data and to keep it all safe. You can see there's like a plastic thing around the coaxial thing and the copper cable in the center. Because if you're a clever hacker, there is a device that you can clip on this coaxial cable and steal the data as you're sending it. Right? That is possible. That's how people steal your data. Okay, and information traveling. And the next one there is probably the one we are all going through now. That's called fiber optic. So most of you are familiar with fiber optic. Most of the homes now and most of the institutions are using fiber optic. Why fiber optic? Can anyone tell me before I continue with this? Anyone tell me why fiber optic? Why do you use fiber optic nowadays? What makes it so fast? Because everyone's saying, you know what, they just installed fiber optic in my house and they're so impressed with it, but they really don't know what they're talking about. They really don't know what it means. So I'm just asking students, do you know what's the difference between fiber optic, coaxial, and twisted pair? Why is fiber optic the best? Anybody? I'm surprised none of you are taking the chance. You all must have asked for fiber optic in your house. You all must have asked for fiber.
Faster.
Sorry?
Fiber optic is faster than the average broadband.
Yeah, we know that, but what makes it faster?
The material that's used in fiber optics.
So what is the material used in fiber optics?
That's copper.
Look at the screen. What's the material used in fiber optic?
It uses light.
It uses glass.
Light.
Light. Okay, but now how does the light travel? We're getting there. I'm probing. I'm getting there.
Uses light.
Need to speak a bit louder. It uses glass. We confirmed that. Someone said it uses light. I concur. But how does it all work? How does it work? Why light? Anybody? Why light?
Light moves faster, moves much faster.
Correct.
The faster speed is.
Okay. So basically you are all correct. We are using fiber optic, and you will notice the fiber optic cable is quite thin. It's like not under, I think it's 3 millimeters. The cable is 3 millimeters thick. I don't see fiber optics around here. I could have shown you. It's all outside. But you've actually seen a fiber optic cable. It's like under 3 millimeters thick. But inside there are glass strands. And as you rightly correctly said, that light travels faster through a glass strand. So your data is transmitted using light through that cable, and it comes into again to a modem that transfers it. Okay, so as you all know, light is nothing can travel faster than the speed of light. If you get copper cable, it's got some resistance in it. If you get twisted pair, also copper cable, there's some resistance in it. But if you take light and you push it through glass, the speed is instantaneous. And that's why we have all the backbones of fiber optic, because at the speed of light it travels. So basically, can you mute your sound, please? Can you mute your mics, please? Okay, to give you an idea of how fast light is, okay, just to give you an idea, simple idea, this is basic common sense. The speed of light from the moon to the earth, from the moon to earth is about 385,000 kilometers, okay? How long do you think the speed travels from the moon to the earth? Anybody? And don't Google it, by the way. Testing your knowledge. Okay, just to continue, it takes 2.5 seconds for the light to come from the moon to the earth. That's fast, am I right? Considering the distance from moon to earth is about 385,000 kilometers. The light to travel from the sun to the earth takes about 8 minutes. Okay, from the sun that you see every morning to earth, that light takes 8 minutes to get to us. And you know how far the sun is from earth? 150 million kilometers. Can you imagine that distance? From the sun to the earth is 150 million kilometers, and the speed that the light travels to reach earth is 8 minutes. Right? That's how fast it is. Why I'm saying all, I'm trying to give you the speed of light through the fiber optic. Now the actual speed of light is 300,000 kilometers per second. Now that is hell of a fast. Okay? So that is why it's so fast when we use light and we push our data through light, and it goes through the fiber optic, and that is how it reaches us so fast. Imagine you streaming a movie on Netflix and you're still using copper cables. You're going to get that intermittent, what's that term that they use? Streaming. And the circle will turn and turn and turn, because it's taking a while to come to your smart TV. But if you've got fiber optic, it's instantaneous. Light of speed of light is 300,000 kilometers per second. That's very fast. That is why we're using fiber optics. But now, just to take you one step further, they are now experimenting with using different colors of light through fiber optic. Can you imagine that? For example, if you're doing audio, let's say they'll use a red light. If you're using video, they're going to send a blue light. If you're using voice, they'll probably send a yellow light. And if you're using text, they'll probably send a green light. So they all got their own different colors, and that will even be more faster coming through that fiber optic. That is how we are moving with technology. That's how fast we are moving. Just to give you an idea, but fiber optic is very expensive, because to cut that edges and to put those clips on the end there is very expensive. You need special tools to do that. So that is why when we have a backbone on our system, we use fiber optic because of the speed. Okay, that's just to give some insight on how fast light travels through glass and through space. So at least you know now, every morning be appreciative. but it takes 8 minutes for the sunlight to reach Earth and 2.5 seconds from the moon to the Earth, and the speed of light is 300,000 kilometers per second. Can you go to the next slide? Just a little bit more on fiber optics. It uses super clear glass strands. It's very fast. The light is durable. Trillions of bits per second. Okay, and it's full duplex. Full duplex. You get single duplex, and you get full duplex. Single duplex only in one direction. Full duplex both directions. So it's very fast. As I said earlier on, it's very expensive and not everybody can install fiber optic. The specialized people that went on special training that can install fiber optics. And of course, it's the backbone of many enterprise systems. So due to Netflix and Showmax and all the stuff that we use on smart TVs now, fiber optic to the home has become a norm. Because people don't want to have the slow down streaming and all of that. That's why most of the homes nowadays, you'll notice that when they're digging up on the side of the roads and the pavements, that is where they're putting the fiber optic cable. Okay, they're digging up all the time and they're laying the fiber optic cable, because most of the TVs nowadays are smart TVs and people are watching movies on movies through Netflix and all of those things. So the house has become a smart home. And that is why you need to be skilled to use the technology in your home. Sooner or later, what is happening now already anyway, when you get home, you got a timer on, the lights come on by itself, you put in your geyser on at different times. If you're very sophisticated, you want to open and close your blinds, you want your underfloor heating to come on, you want your radio and music to come on. If you're a yuppie and you have a lot of money and all of those things, you live in a plush area. And the most important thing is you don't have to control this on your laptop or your desktop. You use your smartphone, okay, all on this gadget here. And of course, you got alarm systems. You can see what's happening in your house. If your domestic is doing a job properly, your child being well taken care of, your mom, your older people, the frail care at home, they are not suffering or whatever. So you can see all of that using your smartphone. That is why it's so important that you must upskill yourself with IT, because that is where we are heading towards. We are living in a digital era, the smart home, the smart office, the smart university, the smart hospital. Sooner or later we're not going to doctors. Many of us don't go to doctors anyway, because when we go to the doctor we are already self-diagnosed. We went to Google and we find out what's wrong with us, and before we tell, the doctor's lives have become very easy nowadays, by the way. Instead of you asking the doctor what's wrong with you, you telling the doctor what's wrong with you, and all he's giving you is a script for the medication, and you're paying him 600 Rand for that. Guys, don't do that. Know what's wrong with you, because you Googled it. Go to the doctor and see the doctor knows his job. If he's diagnosed you properly, do that instead. But don't, the doctor say, oh, this guy already self-diagnosed, so what must I do? I'll just confirm what he's told me and I'll give him the medication. So be wise, okay? Do your investigation, go to him for confirmation, and then even if you're going for surgery, all the surgeries are on YouTube. Go into surgery and see, listen, I'm going to have my appendix removed. Let me see what the procedures are, what the doctor's supposed to be doing. If he makes a mistake, I'll say, okay, you did make a mistake, but I see on YouTube that's how it's supposed to be done. So that is where technology is taking us. You can't bluff and you can't fool people anymore, because everything is out there. All you need to do is to go and find it and educate and upskill yourself. And that's what I'm saying to you. The power of technology is at the tips of your fingers. All you need to do is go there and make use of it to upskill yourself. The next slide just gives you an idea of the various speeds and what costs. Obviously, the twisted pair is the slowest one. That's where we start off. Then we have the microwaves, then we have the satellite waves, then we have the coaxial, and then we have the fiber optics in that particular order. And you can see right now fiber optics is the highest, because as I explained earlier on, that the glass works, the speed works fastest to glass, and you can see that it goes at 6.4 terabytes per second. Now that is very fast. Okay, you just blink your eye, the stuff is there. Okay, and at the bottom there, BPS is bits per second. But sometimes when you're ordering computers or you're talking to your cell phone company, they use this terminology and they try to fool you with it. It's on the screen. kbps, kilobits per second, megabits per second, gigabits per second, and terabits per second is the fastest. Okay.
Just ask them if they can see the slides.
Can you see the slides? The technician wants to know whether you can see the slides. Anybody? Anyone respond?
Yes, we can.
Yes, we can.
Okay, you're all very quiet. I hope I'm not putting you off to sleep.
Yes, we can.
There was one person that said they can't. That we missed.
Okay, there was one person that said he
We're
couldn't.
here,
That's
so,
right.
Are you all alive? Okay, that's good.
yeah.
All right.
Yes, don't see the slide.
Okay, is it not interesting enough, or should I make it more interesting?
No, it's very interesting. That's why we're listening. So.
Okay, but you mustn't only, yeah, that's a trick question by the way I asked you, and you fell for the trap. You said you're only listening, but you're supposed to participate as well. It's an interaction. If it was very interesting, you're supposed to challenge me all the time, and that's how we learn from each other. Because remember the students, remember when you ask a question and I give the answer, you're going to remember it much longer than staying quiet. So what you need to do in order to understand the stuff that I'm telling you, go home tonight and you talk to your wife, your girlfriend, your spouse, and say, you know what, I just want to talk to you about something, instead of talking about all the other nonsense that's happening in South Africa, and talk about all the stuff you spoke about today. Hey, that person, your spouse will be highly impressed with you. She will say, oh my word, this person is highly intelligent, I must stick around for longer because I can learn a lot from this person. He knows everything about IT and I can learn from him. So you'll be very intelligent when you talk to them about these things. Why I'm saying this? And even when you have your social gatherings, talk about these IT things. Because the more you talk about it, the more you inspire other people to become technologically advanced and skilled. And they will say, you know what, my buddy spoke about these things. I didn't know what he was talking about. I'm living in the dark ages here. I need to upskill myself quickly so I can also latch onto this. And by you doing this in your social groups, sooner or later the whole community becomes aware of the IT that's we're surrounded with. The whole country becomes involved, and then we will soon become a first world country that knows how to use technology. It starts with you at home, talking about this to your spouses, to your kids at home. Talk to them, tell them what's happening. So when they talk to their friends, they also talk about these things. Alright, so that's just a bit of motivation on how to get to know about IT. But here's another question. There's something faster than fiber optics. Right? Can anyone tell me what it is? There's something faster than fiber optics. Can anyone take a chance? There's no wrong answer, by the way. I'm just probing you to think beyond the screen and what I'm showing you. Maybe when I expire one day and you guys are still around, you say that can't happen.
Take it as the new 5G.
5G is here already. Like I explained, 5G is also about just making the pipe bigger. But there's something faster than fiber optic. Fiber optic is getting information from point A to point B. The transfer of information. Okay, you've got 3G, 4G, 5G, you've got LTE, you've got Edge. That's all just getting closer, getting speeds faster. Okay, I'm talking about the actual medium to transfer this. There's something faster than fiber optics. I'm glad you answered. At least you are thinking and you're listening to me. But the other 249 people I see online, why are they not answering? Come think.
What about satellites?
Sorry?
What about satellites?
Satellites, okay, satellites is very good answer there, because let me just go to satellite while you're talking about it. So when we go into, because right now, as you know, when you're traveling and when you go to certain places, you always have no connectivity, or there's no connectivity, or there's you have a problem, you can't connect. So as satellites become cheaper, okay, South Africa is trying to launch a satellite that covers South Africa only, and all our cell phone connectivity will go to the satellite, and that means no matter which corner, which cave you creep into, okay, you will get a signal. Because right now, the way it works, your cell phone needs to find the nearest mast or the pole. So that's where the signals are going, am I right? And that pole talks to the next pole, to the next pole, to the next pole. And that's how you receive a connection on your cell phone. All right?
Yes.
So when you go to a soccer match or rugby match or tennis match, and everybody uses their cell phone simultaneously, you will notice that the connectivity is very bad. Am I right? Because there's only one mast, and that poor mast is trying to gather all information, and it can only take X amount.
Yes.
Now, to alleviate that, if we shoot up a satellite into space that's just over South Africa, they can take all that information and bounce it all back, our problems are solved. We don't need any fiber optic, we don't need any twisted pair, we don't need any coax, we don't need anything. We just need dependence on that satellite.
Right.
Right? So that's where we are heading towards. But you know what? South Africa's got the money. You know how much is stole from South Africa. You all know, I don't need to talk to you about that. Now, when we have the right person that's supposed to be in cabinet, that's looking after our technology and all of those things, that was the first thing that he's supposed to do. Listen, we don't want cables, we don't want this, we want a satellite over South Africa. Let's build one, we've got the expertise in the country. Get NASA to shoot it up for us. And we have connectivity all over the place. We don't have to struggle with mast and pole and people burning and stealing the mast and pole. We want a satellite. It might spill over to Zimbabwe a little bit, that's fine. They can steal our connectivity, not a problem. As long as all South Africans are connected. That's what you want, connectivity. So that's the part of satellite that I want to talk to you about. The next level is to go to satellite, high-speed satellite. But we don't want one satellite. We want a couple around us. In case one goes faulty or out of orbit, we've got the backup. Always have a backup. But coming back to my previous problem, what is faster than fiber optic? And this is going to be the future.
Bob, can I ask a question?
Please.
I just want to check with you saying that if once we have satellite, we then not need the other kind of network. Would that mean that then the fiber that's currently being rolled out throughout the country, as well as the masts that are stored everywhere, will that become redundant, or will it be a backup system?
Yeah, it will probably be used as plan B, as a backup system. And remember, should the satellite go out of orbit or get struck by a meteor or some environmental damage causes it, remember, we can always revert back to the normal infrastructure that we have. Put this in, it's there, why take it out? Just leave it there, let it use. Some people will still want to use it, because remember, you still need the connectivity from your computers up to the satellite. So each house, like your normal TV at the moment, you've got the satellite dish on your house. Okay, that's talking to a satellite or to a mast somewhere. That's what it is. So computers will be the same. They are there already, your phones will be the same, but the infrastructure that we have, yes, they might not put in more fiber optic, they might not be installing more masts, no need for that because the satellite is working. And that's how the ships operate at sea, and that's how the aeroplanes fly in the sky using satellites. And I'll talk to that later on. There's something about satellites coming along the way. Okay, but to answer your question, can anybody tell me what's faster than fiber optics?
Just ask them once again if they can see the slides, because there's one person that.
One person of you that's shared your screen and has messed up the screen here.
Just see if they can see it.
Can you see the screen, students?
Yes, we see the screen.
Okay, just try not to share your screen, otherwise it messes up everything here in front of us. Something about to power off here.
There's one person that says they can't see the slides.
There's one person that says they can't see the slides.
There's probably something wrong on their side.
Probably something on your side. Because everybody else can, they can. Let's change the screen.
Change slides.
I also can't see that screen.
What's this 251 seconds to power off? Press any key to cancel. That's someone.
Just the TV.
Okay, if you cannot see the screen, it means that there's something wrong on your side, because if everyone else can see it, then it can't be that something on our side here.
I think it's left side because I was able to see the screen, but now I can't.
If everybody can't see the screen, then there's a problem on our side. If one or two people or more people can see it, then it's a problem on your side. That's a simple diagnosis.
I can see the slides also.
Can
I can see clearly.
okay. So if one person, if one,
I want people to check it, but now I can't. What to do?
There's a lot of people sharing their screens here.
Okay.
With me, everything is clear.
okay. So if you share the screen, it could cause a problem with MS Teams. Be careful. MS Teams is very, very sensitive. It doesn't want you to share your screen. If you've got one computer and 3 screens, it causes problems. I experienced that before. So MS Teams wants to have 1 screen per person. I found that was a problem the other day when I was busy with interviews, that I had 2 screens open and they couldn't either hear me, or they couldn't see me, or they couldn't see my screen. So when I just worked on 1 screen, everything came back to normality. So it's a limitation on MS Teams itself. Okay? Just take note of that for your future lectures. Okay, so coming back to the what is faster than fiber optics. So what is faster than fiber optics is your thought. There's nothing faster than your thought processes, okay? So in the future, you were just going to say that. I knew you were going to say that. Yeah, you knew the answer. Correct. So, Pati, remember I told you, you mustn't feel shy. There's no one's going to say, because they can't see you, they can only hear you. So don't be afraid to say it. Now, sometimes it's not all about IT and hardware and software, it's beyond that. So faster than fiber optics, faster than satellite is your thought. So what's going to happen in the future, they're probably going to give you a helmet that you're going to put on your head. And as you think of certain things, it will be interpreted by the computer and will be activated. It's already there, by the way. Some of the fighter pilots, the jet pilots, when they are bombing or when they are practicing, they've got this helmet on and they think of a space somewhere, say, okay, that's where I must let go of the target, and automatically the missile gets activated and it goes and hits the target. So you're not going to type in anymore, you're not going to talk anymore, just what you think is going to be interpreted using zeros and ones, and it's going to activate the computer and it's going to happen. Isn't that amazing? Okay, so I know some of you are thinking, what if I have bad thoughts or negative thoughts? Well, you've got to start thinking positive all the time and get away with negative thoughts and bad thoughts. Okay, so that is where computer technology is heading towards, where you're going to think of something and it's going to happen. You're going to think of a McDonald's burger right now, the order will be placed automatically, your card will be linked to the system, you will see if I'm a vegetarian, you will see what's that, fries or wings or whatever, and it will be delivered to you. Just by thinking about it, it will be delivered to you. That is where we're going to be heading 10 years from now. It's not impossible. 20 years ago, 30 years ago, we didn't think we were going to start talking like this via MS Teams and streaming and all of those things. It's here. So we need to think where technology is going to take us in years from now. Okay? So thought processes is going to be the way we're going to be moving with information technology in 10 to 50 years from now. It's already being developed, it's already there. They're just going to streamline it more, and that's what we're going to be heading towards. Okay? Right, this screen here talks about the breadth of support for information systems. Okay? So basically we have two types of information systems that supports the entire organization. Out of all these slides that I'm going to be showing you and speaking to you about, there's basically two things that you need to know about that will take you through your daily workspace in your particular environment. Number one is ERP. I spoke about that earlier on, which stands for Enterprise Resource Planning Systems. And the second very, very important one is TPS, or Transaction Processing Systems. Okay, just very quickly on these two slides, the Enterprise Resource Planning System is a software that brings all the other softwares packages together. For example, and there's slides coming along, I think, the HR system, the finance system, the health system, the police system, all the systems that you have in your particular company, the procurement systems, brings all together nicely under one system. Okay, and that's called Enterprise Resource Planning. So everything is in nice one bundle, and that's where most companies are heading towards. In the past, 20 years ago, they used to have for spreadsheets Lotus 123. You guys remember that? Lotus 123 is similar to Excel spreadsheet, and that's what this for doing numbers. Then they had another package called WordPerfect to do the typing. Okay. Then they had another program. I don't think PowerPoint even existed then. Okay. Then they had other programs to do Turbo Cache and something else for accounting packages. And these were all disparate softwares requiring different power resources from the computer and mess up the whole computer systems. Hence, ERP came into play, which puts everything together under one umbrella and you can use it interchangeably in your whole organization. So it sort of packages everything very nice for you, and this is what most companies are heading towards. So it is information systems that support several departments in the whole industry. If you want to know what ERP is about in simple basic language, a lot of systems packaged together in support of the business process. That's all that it is. Okay, it's not any more disparate systems. And then TPS systems. Okay, and this is the support for real-time monitoring, collecting of data, storage of data, processing of data, and basically organizing the day-to-day operations. Now, this is the level, the TPS level, where many of you are operating at the moment. Okay? Now remember earlier on this morning, I spoke about data, I spoke about information, and I spoke about knowledge. Now, the data that you are capturing into the system is at this level here, the TPS level, right? So TPS, this level here, is known or is regarded as the backbone to almost all information systems. Okay, it's the most important part, and if you look at the triangle coming up later on, we can just change the slide please. If you look at this particular house here, at the bottom there you see just below IT services, you got TPS, Transactional Processing Systems, and those pillars that you see there, the accounting, finance, and all of that, that's called the enterprise resource, the ERP systems, and that is known as the functional support systems as well. Okay, but below that, it's resting on the TPS systems, and the TPS system is dependent on, look at what's it dependent on: IT services, IT staff, IT components. So if I remove the foundation there, the 3 layers there, okay, that whole house will crumble down. Am I correct? So now you tell me. So now you tell me now, is accounting more important than IT? Is finance more important than IT? Is HR more important than IT? Is marketing more important than IT? Is BI more important than IT at the bottom? Do I need to answer that question? I don't have to, right? Because the foundation of that house is built on the IT platform. And we are living in the digital era. We are involved in the digital era. The new kids are born in the digital era. So hence, for us as parents and as young entrepreneurs and innovators and young intellectuals for this country, we really need to get to this level to understand that the future of this country and of your family and your society is based on your skills to upskill yourself to ensure that you have a good and solid foundation of IT. Because if you don't have that, everything above that purple block will just crumble down. So that's why I put that diagram so you can visualize. But sometimes it's very difficult to understand this when you're working in an environment. People say, you know what do you know about IT? If my numbers are not right, you don't have a job. The marketing guy say, you know what do you know about marketing? If I don't market this product, you won't have a product to sell. HR say, if you don't have the right person here, this company won't exist. And the IT guy will just say one word: if I pull the plug, none of you will exist. Am I right? So you guys, you got something to work on. You go to your boss and you tell him, listen boss, if I don't do my job properly and I don't capture the data correctly because I'm operating at the TPS level, you will be without a job because you're going to report to your boss on incorrect information which I've captured. So now I'll ask you this question: who's the most important person in your organization? Okay, here's the question again. Who are the most important people in your organization? Looking at the diagram. Sorry?
Your IT personnel.
Anybody else?
Everyone is important in the organization.
Correct, but important, but I'll give you scale. I'll give you scale. Important, very important, not so important.
Head of department.
No. So basically, and this is what I was hoping that I would get a right answer when I spoke to you about the data earlier on. The information. There we go. There we go. The TPS person there. If that is not right, everything else above will be wrong. Alright? So if you don't capture the numbers correctly, the finance person will compute incorrectly. The marketing person will compute incorrectly. The HR person will incorrectly. Everything above that is just wrong. Because the layer there, the TPS, is flawed. So that person there, the TPS where most of you are working at, you are the most important person in that whole business. And you should tell your boss, you know what, you're arguing with me, why it takes so long to capture this information. If I don't capture this information correctly, your job will be at stake because you will be working on wrong information. Imagine you are capturing data for an insurance house, for Johannesburg Stock Exchange, and your information is wrongly, incorrectly captured. What's going to happen? Tell me. You said everybody's important. Do you understand what I'm trying to say here? So this is how you engage when you go for your next increase, when you go for your promotion. Because sometimes some bosses, not all, look down on people that are doing the most important work in the company. Ask me, I know I've been there for 20 years. Right? They look down on the person that's spending the most time capturing that data day in, day out, routine work. But if that's not done properly, everything else above is useless. So think about this next time. If some of you are in senior positions, when you are too harsh on the people below you, on the work that they're doing, to you it might seem menial task, but if that menial task is done wrong, you're out of a job because you're reporting the wrong information. So that's a very important slide. Okay, and on top, the guy on top that's sitting there, all he's doing is looking at what you've captured, what was computed in between, he's looking at his dashboard, saying, okay, today we increased the price by 1%, or tomorrow we decreased it by 2%, based on what was coming from the bottom. But you can only say that if your TPS data was captured correctly. Do you understand why that is so important? So you guys are very important, and don't ever lose focus on that. If someone comes with a master's degree, a doctoral degree, an MBA from XYZ, and you just a plain Joe soap that's capturing data, you can tell him, yes sir, you might be having all those degrees, but if I don't capture my work right, those degrees are meaningless, because you don't know how to analyze the data, because you've got no clue what it is. You are looking at data which I've captured in a nice way. Okay? Right, so the next slide, you can change that bit, is another. I'm sure by now you'll have enough answers to me. Okay, so let's hear some answers. We don't even have to read the case study. Why do managers need IT support? Anybody? Don't even think of 3 questions here. I'm asking you one question. That's highlighted in blue there, or green, whatever the color is. Why do managers require IT support?
To increase production.
Right? Productivity. What else?
It is for record management as well.
That's good for management, proper management. What else? I would thought by now all 249 would have had an answer for me.
Improve decision making.
Good, very good. Help you in making correct, precise.
For smart processing of the information.
Very good for information, smart processing or accurate processing or precision processing, which is your decision support systems, expert systems, all the various systems that we have. Okay, so you understand why managers need IT support. They cannot go without IT support. Because another very, very important reason, we are collecting data at all. Carry on. What time do we break?
We can break in 20 minutes. One. Start at 20 minutes.
Okay, so one of the most important things why managers or senior managers need IT support, because we are working in a digital environment. We are capturing data at every single level, and the data is becoming bigger and bigger and bigger. And as I explained earlier on, we're getting into data warehouses and data marts. The manager cannot analyze all this information himself. He needs computer systems. He needs you guys, the TPS people, to capture and ensure that the stuff is right, to help him make informed decisions because of the voluminous nature of the data that is being collected, because we are living in a digital society. Every time you go to a supermarket and you scan this item, data is collected. Okay, I don't want to go into this now. I'm going to have a break at 1 o'clock. It's a long explanation of how Pick and Pay or all the retailers, why they irritate the daylights out of you when they change the layout of the store. When you go to your Spar down the road, you go to aisle number 6, and you know in aisle number 6 there will be eggs and there will be something next to the eggs, and you send your mother this and you tell the mother, Go to aisle number 6, you see eggs, and your mother tells you, but there's no eggs in this aisle. What are you talking about? Don't blame your poor mother, please. But the eggs will not be there. And I'll explain to you why that happens. I've been retailing for 15 years, and I can explain to you why that happens using information systems, why we do that. Okay, there's a science behind that. Okay, so basically there are 3 types of decisions in any business. You have many other decisions, but the 3 important decisions are: number 1, most of you will know, and we've probably spoken about this with Prof. Pillay, is the strategic decision making. That's very important. That's where it sets your strategy for the business, which direction you're propelling yourself into. The second level is called the tactical level. What do I mean by tactical? Tactical level is the various policies that you have in the business in order to do it. The policy dictates this, how you must do it. And then of course the third level, which is your operational, that's the implementation, how to do it. For example, just to give you an example, in higher education, the new strategic vision now was that we need to have smart universities. We need to start using technology because people are becoming more digitized, and we need to get all our content on the various multimodal online learning, blended learning platforms that everyone study. That's the strategic vision for the whole university. It's been decided, that's where we're going. Okay? So what's the tactical vision of that? Or the tactical vision is the operational part of it, the policy part. Policy there is that we need to ensure that all our academics have the skill to develop and to create content that can be delivered online. That's tactical level. That's the policy must be written for that. Second one is all our students must have laptops and data. Policy, it must happen. That's a tactical level, right? We cannot go to our strategic level where we want everyone to learn online, when at the tactical level we don't have a policy to say how we're going to deliver it. The how part is that students must have laptops and data, and they mustn't pay for it. Because I believe laptops and data can be affordable for every single student in South Africa to learn. The government has the money, but they are not using the money properly. Okay? I would rather have a literate young youth than an illiterate young youth. I would rather spend the money to ensure that every single South African is educated, they can use a computer, and the computer must be readily available for that person, and to have data available for that student. Because in 20 years from now, we want to see a smart South Africa, okay, where everyone can go anywhere and use a laptop, anywhere, any place, anytime, or the computer or the smartphone. It must be a norm. Okay, the last part is the operational. How are we going to go out and do it? Okay, the universities must change their way of functioning. Multimodal must ensure that the bandwidth is increased, so we can put more broadband speed into it. That we have VPNs. Okay, I use a term which I have explained earlier, but we'll come to that in the cloud. So we have VPNs, and that all students have the right to a free quality education which has a laptop and data, and they should be able to work from home, because if COVID doesn't go away, that's where we're going to learn from. Okay, so that is the thinking that all of you who are young adults, still growing up, or still growing, maturing, going to the next level, and you've got kids growing up, that's where we want South Africa to be. Okay, we don't want to have a super intelligent people that know everything, and someone in the rural area that don't know what a computer looks like. That's unfair. That's totally uncalled for. We cannot have that. We must have that skill. Okay, so those are the 3 levels that most businesses operate: the strategic, the tactical, and the functional, or the operational. All right. So, are we still good for time? Yeah. Okay. So, the next slide. Why managers need IT support. That's slide number 27. Yeah. Yeah, same one. Sorry, our slide. Yeah. Okay, the next one. Breadth and support. 28. There we go. So here's a new term that I am introducing. It's called iOS, and many of you in government are using this. Believe it or not, but this is just the IT name for it. Inter-organizational information systems. So what is that? So you are working in government, you're doing some form of procurement, you've got your suppliers out there, you've got the people that create tenders that's working with you. So when you work with another supplier, with your company, and you're sharing a similar database with products and services, and you have a link between the two, that is called an inter-organization information system. So you might be having the same enterprise-wide systems and you're linked to each other. Now the program that does this very nicely is called SAP. All of you know what SAP program is. Most of the municipalities use SAP. Okay, so an inter-organizational system, or an iOS, supports many inter-organizations. I'm muted. Okay, somebody muted us. Maybe I'm talking too much.
Yeah.
Okay, so inter-organization information system are the suppliers and the people that you work with within your company in order to do your job, and you're all linked on the same platform. Okay, an example of an iOS will be supply chain management. So you're in the procurement place and you want to secure stuff, so you don't want to create a separate entity, you want to link them to your business so the flow of information is faster. For example, if you are in the motor car industry and you are manufacturing motor cars, okay, now you've got a big factory, but you don't want all the windscreens to come on the same day or the same week because you don't have storage space, and you have a risk of someone might be damaging the windscreen, or someone throws a spanner, or something gets mislaid and the windscreen cracks. So you want to do something called just in time. Okay, I'm going to operations management now. So you want that windscreens to come just in time when the vehicle has completely been manufactured, and now is the time for the windscreen to be installed. But now you don't want to phone the supplier of the windscreens. Listen, in 2 weeks time, I think I'll have 100 cars available and I need 100 windscreens. You don't want to do that. You want to work smart. That supplier of the windscreens must be looking at your system and say, okay, I see Mercedes-Benz. They've got 100 Mercedes-Benz on the line. In 3 days from now, it will be ready. I need to get my logistics right here and get those windscreens wrapped up and properly secured. So 3 hours before those windscreens need to be installed, my delivery truck must be 20 minutes away from that warehouse. So when it comes off my truck, it must go straight to the Mercedes-Benz and must be installed. Now, isn't that wonderful? Mercedes-Benz will lower the risk of a windscreen being damaged. They will save on warehouse space, and the product arrives just in time. Now that is where we are heading towards. That's where we must work towards. And that's what inter-organizational systems will do for you. So the government gets a tender to build 100 houses. Okay, you guys might laugh at this. You give the tender to your tenderpreneur, and suddenly you give him the 100 million to build the homes, and that's the last you see of the 100 million, and you go there 9 months later to go to the land. The home's supposed to be built in some rural area for the poor people, and when you go there you just see a vacant land and vagabonds living on it. Not fair. That's your tax money. If we have inter-organization systems running, you say, right, Mr. Tender from here, you won the tender. Now, at level 1, you will see on the system that you've done the roads. Once you've done the roads, you get your first tranche. You don't have to come to us. We can see on the system here. You must also be on the system. Right? Second level, you put the pipes in, right? Now you pay for the pipes. And so forth and so forth, and eventually that 100 or 1,000 homes will be built. Am I right? But what do we do in South Africa? The direct opposite. The tender comes in there, he doesn't know how to even build a house. You give him the money because you want to support BEE, he goes and he gives that 10 other people to build a house. 10 years down the line, the homes are being built, the poor person that needs a house is still living in a shack. That's not fair. That's not right. We can't think along those lines. We need to use systems to get our country right. And you are in the space now to get it right. And you tell your boss, you know what? Why are you giving that man money? Get him on the system. We pay him only when he has delivered. That's how it's supposed to be. Because you are all in government. You got control. You can make it happen. It starts with you. And that is how we use IT in social development to make sure what government was supposed to deliver to the most needy. And it could be your family and friends. You could be living in the comfort of home, but tomorrow that can be taken away from you. Think about the poor guy, winter's coming up soon, that's living in a poor shack. It's not right. But you are right there in government. You have the skill to say, listen, no, we don't do this. We use a system to ensure that we deliver to our people. They are all your people, my people. We are together. We are human beings. We can all live beautiful in this country. There's enough resources to go to share amongst all of us. Okay, why must one person have the best of the best and the poor person must eat from the bin? That is not right. I don't ascribe to that. There is enough. But you know what? You are there using information technology and systems to point out to your managers or the people that are doing this corruption not to do it. And the systems can block them and tell them, listen, use inter-organizational systems, use the supply chain management system, use the enterprise resource planning system to curb all this corruption that is happening in our country. Because our poor people cannot suffer another 20 years to get a home to live in. That is not right. It's wrong. I drove into Durban after 15 years and I saw all those shacks and I just said, this is just not right. Why must people suffer and live like this when we have the wealth in the country to deliver a decent home for all our people? So, colleagues, I won't call you students now, colleagues, use information systems to make a change in the country. That small change that you make impacts thousands of lives out there. If you're in charge of procurement and you got a tender that a house or a road or water or something must be installed, and you know you can use systems to prevent someone from looting the money, please do it. You will be rewarded somewhere along in your life for doing a good deed. Alright? So enough of that lecturing. But I just wanted to show you how ICT can make a change in the country. That was the point behind that. Can we have the next slide? Now this is probably a beautiful slide that puts everything, that packs everything together what I just spoke about. Okay? In the center there, I don't have pointing here where you see customer relationship management. That's very important. That's where you are sitting at the moment. Okay? And then onto my left we have the suppliers that's trying to do business to business commerce with you in government. Very important. That little thing in the center there is called the internet or the cloud, and the one on top there is called also online payment, digital. These are all linked. This is how the enterprise works. Everything is linked to each other. This is how inter-organizational systems talk to each other. And your tenderpreneurs that's tendering with you, you know what, instead of saying you need to have all the BE status in black and white, tell them, are you linked to all of our systems? Can you talk to us using inter-organizational systems? Because that's how we're going to communicate and see what you're doing. That is important. Not saying, you know what, you need to have so many XY partners in your company before we give you the tender. No, we want to see what you are going to deliver to us on the money that we are giving you. And here you can see customers over there, individuals. They are the ones that are at risk for that, for not getting that house or that road or that tap or that water that's supposed to be delivered to them. So this is a cyclical process which talks to everyone at the click of a button, or looking at your smartphone, you can see actually what is happening on that particular slide. So you've got suppliers there, I made a note, you've got the business talking to each other, you've got the customers talking to each other. So in that triangle, it's you, your organization, the government. You've got a finger on the pulse of everything. So you cannot say, like they say in the Zonda Commission, I did not know it was happening. I did not know this was happening. I don't recall that was happening. If those people only use information systems, we would not have been having a Zonda Commission. Do you understand what I'm trying to say? Because everything would have been recorded on the system, and you could see exactly who did what, who stole what from the poor people in this country. So systems can really help this country. Systems can really put us on the map. And you know what? The frightening thing is, we can get this country out of this mess within the next 5 years if we just implement systems in all our 9 provinces without any paper intervention, and everything is done digitally. But then you can go back and trace and see who did what and what went wrong. Within 5 years, if the young generation can get into these various strategic departments, your children will have a better future in this country, and they wouldn't want to leave this country and run away to another country. But it all starts with you upskilling yourself to make sure that corruption doesn't happen, by ensuring that you follow these things, simple things, okay? But the skill that you have can make a change in the lives of your children and your grandchildren in years to come. So wonderful country, we can make the change happen, but ICT is here to help us. Remember, I don't believe in working hard. The days of working hard is over. We can't work hard anymore, no. We must work smarter, right? We're living in a smart era of digitization, and we must work smart to do our work. A little bit of common sense, a little bit of intelligence, a little bit of intellect. We don't want to be clever anymore, no. We leave that for someone else. We want to be intelligent, we want to use our intellect, and we want to think beyond the norm, we want to think out of the box, and information systems will take us there. So that particular slide on the screen packs it nicely to show you how you can interact and support people by just using your technology skills that you have, take it to the next level, push it to the next level. But yes, you must say to me, Prof, you know what, you've learned all the skills, but my manager is still from the dark ages. He doesn't like technology. He doesn't want to go to the next level. And that is a problem. Maybe he must come on his course. Maybe you must inform him and tell him in a nice way. Don't make him look small, but then he's going to have a grudge against you. So use tactical discussions with him. Say, but you know, manager XYZ, if you do it this way, we can save so much, we can do that, you will look good. Make him look good. Okay, on your ideas. Don't worry about it. Later on, you will be rewarded. Okay, so think about these things very carefully when you are in your position. With you at the strategic level in your position, you are at the TPS level, and you can make the change. So I think, Vic, we can have a break now at 1 o'clock. When do we come back?
2.
At 2 o'clock. Okay, so Vic tell me there's 250 you that are online, you can see. Please, all 250 you, I want to see you back, because there's very, very, very exciting things coming up after this. Very important things, real stuff. What I spoke to you earlier on is very, very elementary. I hope it made some impact to you, but now the nice stuff comes. You know, the stuff that's really going to make your eyes open up, and really want you to go on to all the IT courses. And I really want to finish all of these things in there, because I've spent a lot of time going through those 6 different books to give you all this information. So have a break for 1 hour, time come back, and we will continue and see how far we get. Alright, thank you. Am I still on?
You are.
Oh. Sure, my voice is gone.